We're going to talk about the oil pump. Early engines, very early engines, didn't have an oil pump at all. They were lubricated by dripping or splashing oil onto the moving parts. So a large engine in something like a ship or a factory would have a person whose job was an oiler. And then the oilers would go around with a container of oil and refill lots of little pots that dripped oil down onto moving parts. So if you had a large bearing, above there would be a pot full of oil that would drip onto the bearing and then drain onto the floor into a tray and be collected later. And the very first cars just dripped oil, onto the components and then down onto the road or the grass or the mud or whatever it was driving along. Obviously, that's not a sustainable situation when your cars travel at more than 4 miles an hour, or a journey of 10 miles was an epic trek back in those days. So what we have is what's known as a force feed lubrication system, which is where we have a pump, an oil pump, which forces lubricant around the engine to all the various places that it's needed. This is an oil pump, and we'll explain the way an oil pump works by building this oil pump from scratch using all the various pieces. The first thing that we'll look at is this, the oil pickup pipe. Here is our oil pickup pipe. This sits in the sump and it sits below the level of the oil. On the end of the pickup pipe we have a strainer, which is a very coarse filter to filter out the large dirty particles in the oil. And that oil goes into the inlet on our pump. So here is our oil pump, or our oil pump housing, and the oil makes its way up through a inlet here and into the pump. There's two different types of oil pump. We have a gear type oil pump, which is where you have two gears that spin and the teeth interlock. And we have this type of oil pump, which is called a rotor type or a gerotor type oil pump. This is the most common on vehicles. So to show how this works, we'll bring in the parts and build up this pump assembly now. With our rotors installed, we can see now how this pump works. So oil comes in through this inlet pipe here. Oil comes in here, in this direction, and it enters in. If we pop these out, we have a void inside, and in here is the oil. So the oil comes in there and the oil travels out along this pipe here, through this hole here and into the engine block. So we want to move the oil from this side of the pump to this side of the pump. This is our outside. We're going to send the oil through there, and this is our inside. And the job of the rotors is to carry the oil between those two sides. With the rotors installed, there would normally be a sealing plate on here that seals the inside, but so that we can see what's happening, we take that off. So let's take a look at the way these rotors work. The inner rotor is turned by the crankshaft, so as that rotates, the inner rotor turns around and that also carries the outer rotor around. The outer rotor has one extra tooth or one extra lobe, which means that the two move around. So let's take one void, one gap between these teeth to demonstrate. Let's look at this gap here. So we can see here, as this inner gear rotates, we have a gap here. This is our gap that we're interested in, right here. And at the moment, it's this S shape. So as we begin here, the rotor turns, the gap opens up, it increases in volume, there's a bigger space here, that sucks in oil from the inlet side here, and it's continuing to expand as we rotate around until we get to about this point. Once we're here, this is the maximum size of this void. So at this point we have a void full of oil, and as we come across here, we move from the inlet side across a seal here, effectively a sealing surface. This oil is now trapped inside this void. And as we continue around, that void now begins to shrink, decrease in volume. That forces, squeezes all the oil that was trapped in that void out and through the outlet side of the pump. So, and this is happening with every void on this rotor system. So each of these voids is expanding on its way around here. It's now moving across the seal with the trapped oil inside, and now it begins to shrink, force that oil out of the gap in the gear and through the outlet side. And that is how these type of pumps generate enormous pressures, because there is no alternative for the fluid in there than to be forced out of the outlet side. It's trapped. It has to be squeezed out of this gap. And these are enormously strong gears here, so there's a real strength in here, an ability to compress, well, not to compress, but to pressurize and force this liquid through. On this engine, the oil pump sits directly over the crankshaft here, and it's driven around by the crankshaft itself, and the oil makes its way out of the outlet here on the oil pump and into the engine block through this hole, which is sealed with a rubber grommet. So the oil goes into the engine along this shaft and into the oil filter. As the rotors are spinning on this pump, we have a constant flow of oil from the inlet side to the outlet side. This type of pump is what's called a positive displacement pump, and that means that the amount of oil that enters the pump is exactly the same as the amount that leaves. In other words, we have a constant flow of oil. If the crankshaft is turning and the engine is running, then oil is being moved from one side to the other. And that can cause an excess of oil pressure. We need some way of regulating the oil pressure so that we don't end up with more oil pressure than is good for the engine. The way that happens is inside the pump here, we have an escape route for the oil. So we know that we're coming in here with the oil and the oil is leaving along here and making its way into the engine. But we also have this route here along which the oil can flow, and down at the bottom we have an assembly which is made up of a plunger which sits inside this tube, and the oil presses on the plunger, and once we get to a certain oil pressure, that will force the plunger down and the oil will escape through these small voids and back to the inlet side of the pump. In other words, if there's too much pressure here, that oil goes back to the inlet side of the pump and comes back around. So this is a way to set a maximum oil pressure for the system. That pressure is set by this spring. So we have the plunger inside this tube. The plunger is pushed up by this spring, which rests upon this spring seat. If the pressure release valve doesn't work, then we'll end up with damage to the engine. And the spring is held in just with a little clip and a split pin on this. So that's how the oil pump works. Now we can install this on the engine and see how it's actually driven. But the thing to note with this is that the faster the engine turns, the faster the engine's running, the faster the oil pump is going, the more oil is being pumped. And that's perfect, because with the engine running at high speeds, we want a greater volume of oil. We want that extra oil lubricating those bearings. And the heat is also higher in the engine, which can be carried away by all the extra oil. So I'll coat the insides with oil, because once this is running, we don't want to start this dry with no oil. We'll also fill this with oil. Now I screw on this back plate, add a small gasket around there, and we bolt this onto the engine.